Hello friends, welcome back to another science video from the realm of science. Today I will talk about a question you all must have thought about before. Why does the earth spin? Or more appropriately, why do most of the planets spin? A very simplified answer is that they spin because they were born spinning. To understand this, let's go back in time. About 4.5 billion years ago, our solar system started as clouds of interstellar gases and dust. What happened was that most of these clouds compressed due to their own gravity to form the sun. The clouds which were not used up in making the sun formed a disk around the sun, orbiting the sun. The leftover in this disk started to compress under its gravity and became what we now call as planets, asteroids, moons and comets. Everything in these clouds was in constant motion, and these clouds were orbiting under the gravity of the Milky Way. This motion in the clouds and the gravitational pull was likely to cause a slight rotation in the clouds. We call this rotation as its angular momentum, which is conserved. This angular momentum of the clouds caused the planets to rotate, which had originated from the same clouds. What keeps the planet spinning is Newton's first law of motion, or inertia. It states that a body will stay in uniform motion unless an external force is applied. There is no external force being applied to the spinning planets as space is made up of vacuum. Now, everything in our solar system is spinning at a very different rate. It is not so that everything is spinning at the same rate. Some factors affect the spinning rate of these celestial bodies. We will discuss the important factors now. The very first one of them is the speed and the direction of the spin of the components of the planets. Suppose if there was a component that spun in the clockwise direction at a spinning rate and its radius equal to another component spinning in the anti-clockwise direction. These components, if collided to form a planet, the planet would have no rotation, as the angular momentum of both the rocks would just add up to 0. So, the spinning rate and the direction of the spin of the components of the planet are a very important factor deciding the spinning rate of the planet. The second important factor is the collision of the planets with other celestial bodies. A collision between a planet and other debris in space can cause a change in the speed of rotation, direction of rotation, and sometimes change in the axis of rotation. An example of the following is the Uranus unusual spin axis. The spin axis of Uranus is at a tilt of 98 degrees compared to our Earth's spinning axis, which is at a tilt of 23.5 degrees. It is to be believed that Uranus was collided by a very massive object, which caused such an unusual spin axis. The third and last important factor is the tidal effect. The atmosphere or the liquid on the surface of the planet is affected by the gravity of the nearby celestial objects. For example, the moon's gravity causes high tides on our planet. This causes friction between the tides and the land. This friction can slow down the rotation of the planet. Another example is of Venus. Venus has a very dense atmosphere. The sun's gravity pulls this dense atmosphere, slowing down the rotation of Venus. It is to be believed that because of Venus' dense atmosphere, its rotation slowed down so much that it started rotating in the opposite direction. That's all for today. If you have any queries regarding the topic I discussed today, please do write it in the comment box. If you felt that my video helped you increase your knowledge, then do like my video and share it with your friends so they can also enjoy such interesting science topics.